Solving systems using elimination. Okay, again, systems are basically when you have two or more equations, and we're going to work with just two equations, and we're trying to find the values for x and y that will satisfy both equations at the same time. So, elimination, we basically have to be able to combine the two equations in such a way that either the x's or y's are eliminated or cancel out. So that means you basically need additive inverses. A positive and negative value, maybe a negative five and negative 5x and a positive 5x, a 3y and a negative 3y. Those will be additive inverses, and they will cancel each other out or be eliminated. So that's what we're looking for. Okay. On number one, we do have additive inverses. We have a 2x and a negative 2x. So these two equations can be combined, and we will get elimination. So combine the 2x with the negative 2x, easy eliminate. Combine the 3y and the y, we end up with 4y's. And combine the 13 and the negative 1, that becomes 12. Dividing by 4 on both sides to finish isolating y, we get y equals 3. And there's our solution for y. Now, to finish this, we're going to use substitution. So let's make a line of demarcation. And the equation I'm going to use for substitution will be the first one. So we're going to use 2x plus 3y equals 13. We're going to place the y here with the 3. So this becomes 2x plus 3 times 3 equals 13. This multiplies and becomes a 9. So we have a 2x plus 9 equals 13. In the isolate x, I'm going to subtract 9 from both sides. End up with 2x equals 4. Now divide both sides by 2. And we now have x equals 2. So, in conclusion, x is 2 and y is 3. And we write this as a coordinate. Okay, number 2. Number 2, we do have additive inverses. We have a 4y here and a negative 4y there. So those are additive inverses. So we can add the two equations together or combine them. So we'll get 6x's. The y's will eliminate, equal. And so we combine the negative 2 and 20, we get 18. Now divide both sides by 6. And we end up with x equals 3. Okay. So now I'm going to find out what y is using substitution. So let's go with 2x plus 4y equals negative 2. And for x, we're going to put in the positive 3. Okay. Now, multiplying the 2 and 3, we'll get a 6. Plus 4y equals negative 2. Here, I want to subtract 6 from both sides and then divide both sides by 4. Okay. So 4y equals negative 8 divided by 4. We end up with y equals negative 2. So I will demonstrate the solution as a coordinate where x is 3 and y is negative 2. Okay, number three. Number three, you'll notice that it does not readily have any additive inverses for the variables. You have a positive 2x, negative 4x, and 3y, and a positive 2y. So no additive inverses here. So we're going to create additive inverses by getting a common factor. So I think I can get a common factor of 4 between these two. So if I multiply this entire equation by 4, we will get a positive 4x. So let's multiply this entire equation by 2. And that will turn this expression into a 4x plus 3y, 4x plus 6y equals negative 26. And we'll keep our negative 4x plus 2y equals negative 2. So we'll keep that expression. Now, we can go ahead and combine these. The x's will cancel. We'll get 8y's. Let's see. Then we'll combine these two. So we get the negative 28 here. Make sure I wrote everything down correctly. That's a positive 13. Oh, sorry. That's a positive 13. So that'll be a positive 26. Let's change that. And this part right here will make this a 24. Okay. All right, that's better. Okay, now that we've kind of corrected this, let's divide both sides by 8, and we'll get y equals 3. Okay. Now I'm going to use substitution to solve this. And notice we now have 4 different equations that we can use. I'm going to choose to use the first one right here, 2x plus 3y equals 13. And we'll make a substitution of y is 3 here. From here, we're going to multiply these two. 3 times 3, you get a 9. Then from here, I'm going to subtract 9 from both sides. Okay, that gives me a 2x equals 4. Dividing both sides by 2. Gives me an x equals 2. So I would describe the solution as a coordinate of x is 2 and y is 3. All right, let's look at number 4. Number 4, we have no additive inverses, but we do have opposite signs. We have a plus and minus here. So I want to get a common factor for 6 and 4. The common factor for 6 and 4 will be 12. So let's turn both of those into 12s. This will become a positive 12, and we'll turn this one into a negative 12. So multiplying by 2 will get us a positive 12 here. Multiplying by 3 will give us a negative 12 there. So this now becomes 6x plus 12y equals negative 6, and 8x minus 12y equals 16. And now we have our additive inverses. And we can use elimination now. So we'll combine these two and get 14x's. These two will eliminate. And when we combine these two, we'll get 54. Okay. So let's divide both sides by 14. Let's see here. Does that divide even? Let's find out. Let's see. Half of 54 is 27. Half of 14 is 7. Am I getting any even divisions? Let's see if I made any mistakes with my negatives and positives. Okay, that's 20, 3, 6, 1. Seems like I recorded everything correctly. Let's see here. Oh, I see what I did. Times 4 should be 12. Okay, 12 there. And let's take away this line here. Okay. Let's see what we say. All right, so we'll combine these two. We'll get an 18x. These two eliminate. Over here, we'll get a 54. And now let's divide both sides by 18. And I think it divides evenly. 3. 3 times. So x equals 3. Okay, that works. Okay, now let's put 3 into one of the equations. So we're going to do substitution. So I'm going to use 3x plus 6y equals negative 3. Okay, so the x will come with 3. We're going to multiply these two and become a 9. And I want to subtract that 9 from both sides. It gives me 6y equals negative 12. Dividing both sides by 6. We get y equals negative 2. So I would describe our solution of the system as x is 3 and y is negative 2, written as a coordinate.